Welcome to Astronomy Daily, your go-to podcast for the latest and most fascinating updates from the vast expanse of space and the cutting edge of astronomy. I'm your host, Anna, and I'm thrilled to have you join me today as we dive into some truly exciting developments. From the ongoing saga of bringing Martian samples home to satellites with digital brains, and even the possibility of our own signals reaching alien civilizations, we've got a lot to explore. Plus, we'll take a stunning look at how Hubble is helping us unravel the mysteries of dark matter. So buckle up, because we're about to embark on another cosmic journey. Let's kick things off today by turning our attention to Mars, specifically to NASA's Mars Sample Return Mission, or MSR, which has been facing some significant hurdles. The Perseverance rover, which landed on the Red Planet in 2021, has been diligently collecting intriguing samples, all in preparation for this follow-up mission to bring them back to Earth for analysis. However, recent independent reviews have cast a shadow over these plans, indicating that the costs for MSR could balloon to an astounding $11 billion. This steep price tag has led to the mission facing potential cancellation in the upcoming Trump administration budget proposals for 2026. But there might be a lifeline for this crucial scientific endeavor. Aerospace giant Lockheed Martin, a company with deep roots in Mars exploration, having built 11 of NASA's 22 Mars spacecraft over the years, is stepping forward with a new proposal. They're offering a streamlined, more cost-effective mission architecture, aiming to execute the Mars sample return as a firm fixed-price solution for under $3 billion. That's a significant reduction compared to the current estimates of $7 billion. Their approach involves utilizing existing designs and streamlining operations for the primary spacecraft and systems, while carefully managing risk and reducing oversight. This would include a smaller lander, a smaller Mars ascent vehicle, and a smaller Earth entry system. The lander, for instance, would build on the successful heritage of NASA's InSight lander, which had a smooth touchdown on Mars in 2018. Lockheed Martin also highlights its extensive experience with sample return missions, having designed and built the spacecraft and return capsules for all three of NASA's robotic sample return missions, including the recent OSIRIS-REx asteroid sample return mission, which brought samples from asteroid Bennu back to Earth in 2023. Lockheed Martin believes that by taking a commercial industry approach, focusing on key requirements, leveraging flight-proven elements, and limiting new designs, they can bring back the samples that hold the potential to unlock Mars's mysteries and lay crucial groundwork for future human missions to the Red Planet. However, Lockheed's plan isn't the only alternative on the table. Private space company Rocket Lab also put forward its own cut-price proposal last year, responding to NASA's call for ideas to bring these precious samples home in a faster and more economical way. And it's not just American companies vying for this challenge. China is also actively working on its own robotic campaign to collect and return Mars samples. Their Tianwen-3 mission is set for launch in late 2028, and if successful, could make China the first to acquire historic red planet samples, potentially holding evidence of life beyond Earth. Interestingly, the U.S. approach to Mars seems to be undergoing a broader shift, moving away from purely robotic missions and more towards putting astronauts on the red planet. This direction is reflected in the current administration's budget proposals, likely leveraging advancements like SpaceX's in-development Starship megarocket. While landing humans on Mars is a far more complex and challenging undertaking, if realized, it would also bring invaluable Martian rock, dust, and atmospheric samples directly to Earth, potentially even more comprehensively than a robotic mission. It's a fascinating time for Mars exploration, with multiple pathways being explored to unlock its secrets. From the red dust of Mars, let's now pivot to something truly innovative happening much closer to home, right here in Earth's orbit. Imagine a satellite, no bigger than a mini fridge, that's about to change space technology as we know it, and it's happening at an almost unheard-of pace. Researchers from UC Davis have developed a groundbreaking satellite system that can monitor and predict its own condition in real time, all thanks to artificial intelligence. This marks a significant milestone, the first time a digital brain has been built directly into a spacecraft to operate independently in orbit. What makes this even more astonishing is the speed at which it's come to fruition. The entire project, from initial planning to its upcoming launch in October 2025, will be completed in a mere 13 months. This shatters the typical multi-year development cycles for satellite missions, largely due to a unique partnership between university scientists and engineers in Proteus Space, creating what they call the first rapid design-to-deployment satellite system of its kind. The real star of this mission is its custom payload, a special package inside the satellite that houses a digital twin. Now, you might have heard of digital twins before, but typically, these computer models of spacecraft systems reside on Earth and receive updates from space. This new innovation is different. This digital twin lives and works inside the satellite itself. This means the satellite doesn't need to constantly phone home to understand its own health. Instead, it uses its built-in sensors and software to continuously check the status of its batteries, monitor power levels, and even anticipate potential future issues. As Adam Zufall, a graduate researcher on the project, explained, the spacecraft itself can let us know how it's doing, which is all done by humans now. The artificial intelligence at the heart of the system doesn't just collect data, it learns from it. Over time, the satellite's brain is designed to get smarter, improving its ability to predict how its batteries and other systems will behave. This incredible capability allows the satellite to adjust its operations autonomously, proactively heading off problems even before they fully develop. Professor Stephen Robinson, who directs the lab that built the payload, highlighted this, stating, "It should get smarter as it goes and be able to predict how it's going to perform in the near future. Current satellites do not have this capability." This cutting-edge technology is the result of impressive teamwork, bringing together experts in robotics, space systems, computer science, and battery research. Graduate students have played a major role, contributing to everything from the spacecraft's software design to how the AI makes its predictions. Once launched from Vandenberg Space Force Base, the satellite will enter low Earth orbit, where it's designed to remain active for up to 12 months, rigorously testing its smart brain in the harsh environment of space. After its mission, it will safely deorbit and burn up in the atmosphere, ensuring a clean space environment. The implications of this self-monitoring satellite are vast. Currently, ground teams are constantly managing spacecraft, running checks, and responding to problems, which leads to delays, increased costs, and added risks. By embedding real-time digital twins on board, future satellites could adjust to problems on their own, whether it's shutting down failing parts, conserving power, or warning engineers of impending issues days in advance. This innovative approach promises to significantly reduce the workload for ground teams and vastly improve the life and safety of space missions. This small satellite could truly spark a major shift in how future space systems are built and operated. Now, from cutting-edge satellites, let's turn our gaze outward, far beyond Earth's immediate vicinity, to a fascinating and perhaps slightly unsettling question. Are we inadvertently broadcasting our presence to intelligent alien life? New research suggests we might already be doing just that, sending out signals that could inadvertently scream, "We're here, come find us." According to this new study, military and civilian radar signals emanating from Earth could serve as a beacon for advanced alien civilizations, indicating the presence of intelligent life on our planet. These hidden electromagnetic leakages could potentially be visible to aliens up to 200 light-years away, provided they possess state-of-the-art radio telescopes comparable to our own. This concept, of course, works both ways, offering clues on how far out in the cosmos we might be able to detect similar signals from other advanced civilizations. Ramiro Case Said, the team leader and a researcher from the University of Manchester, explained that their findings suggest radar signals, produced unintentionally by any planet with advanced technology and complex aviation systems, could act as a universal sign of intelligent life. This research supports both the scientific quest to answer the perennial question, "Are we alone?" and our practical efforts to manage the influence of technology on our world and beyond. The team specifically highlighted major global aviation hubs, such as O'Hare International Airport in Chicago, John F. Kennedy International Airport in New York, and Heathrow Airport in London. Their simulations revealed that the combined radio signals from these airport radar systems, which constantly sweep the skies for aircraft, are strong enough to be picked up by powerful telescopes located as far as 200 light-years away. This means that if intelligent life exists on a potentially habitable world like Proxima Centauri b, which is a mere 4 light-years away, their radio telescopes could already be detecting our leaked signals. Military radar signals present a slightly different scenario. These signals are more focused and directed, creating lighthouse-like beams that sweep across space. As Case Saeed noted, these military signals would appear clearly artificial to anyone watching from interstellar distances with powerful radio telescopes, and can even appear up to 100 times stronger from certain vantage points in space. Beyond the exciting implications for the search for extraterrestrial intelligence, or SETI, this research also offers valuable insights for perfecting our terrestrial radar systems and understanding the broader impact of human technology on our cosmic environment. It truly makes you wonder who might be listening out there. From thinking about who might be listening to our signals, let's now shift our focus to what we can observe in the vastness of space, particularly a new, breathtaking image from the Hubble Space Telescope. This image zeroes in on Able 209, a truly colossal galaxy cluster situated approximately 2.8 billion light-years away in the constellation Cetus, also known as the Whale. Hubble's latest portrait reveals more than 100 gleaming galaxies within this cluster, presenting a mesmerizing sight. However, what we can visually see is only a fraction of the story. These galaxies are separated by immense distances, stretching millions of light-years apart, and the space between them is far from empty. It's filled with scorching, diffuse gas, which is only detectable through X-ray observations. And then there's the most mysterious component: dark matter. This invisible form of matter doesn't interact with light, yet it makes up a significant portion of the universe. In fact, scientists estimate that the cosmos is composed of about 5% normal matter, 25% dark matter, and a staggering 70% dark energy. Clusters like Abell 209 are incredibly massive, so much so that they actually warp the very fabric of space around them. This distortion bends the light coming from even more distant galaxies located behind the cluster, a phenomenon known as gravitational lensing. This acts like a natural cosmic magnifying glass, enabling scientists to study galaxies that would otherwise be too faint or simply too far away to observe. While this particular image of Abell 209 doesn't display the dramatic rings often associated with gravitational lensing, it still shows subtle signs of this effect. You can spot streaky, slightly curved galaxies nestled within the cluster's golden glow. By meticulously measuring the distortion of these background galaxies, astronomers can precisely map the distribution of mass within the cluster, effectively illuminating the underlying invisible cloud of dark matter. This vital information, which Hubble's exquisite resolution and sensitive instruments help to provide, is absolutely critical for testing our theories about how our universe has evolved over cosmic time. That brings us to the end of another fascinating journey through the cosmos on Astronomy Daily. Today, we've covered the ambitious plans to rescue the Mars Sample Return mission, the groundbreaking AI-powered satellite poised to revolutionize space tech, the intriguing possibility of our airport radar signals reaching alien civilizations, and Hubble's incredible work in unmasking dark matter in the distant Abell 209 galaxy cluster. Thank you for tuning in and exploring these cosmic wonders with me, Anna. You can catch up on all the latest space and astronomy news with our constantly updating newsfeed and listen to all our back episodes by visiting our website at astronomydaily.io. Don't forget to subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts to ensure you never miss an episode. Until tomorrow, keep looking up.